What if one of the most powerful scientific machines ever built just detected something humanity was never supposed to see? Deep beneath the border between Switzerland and France, thousands of scientists work inside a gigantic underground laboratory known as CERN. Most people have heard the name before, but very few truly understand what happens there. Inside enormous tunnels stretching for miles, particles travel at speeds approaching the speed of light before smashing together with unimaginable force. Scientists built this machine to study the deepest laws of reality itself. They wanted answers to questions that have haunted humanity for generations. What is matter made of? How did the universe begin? What hidden forces shape existence? But recently, strange discussions began spreading quietly throughout scientific circles. Certain observations, unusual measurements, and unexplained anomalies have raised difficult questions that some researchers hesitate to discuss publicly. Because what CERN may have detected could challenge humanity's understanding of reality itself. Human beings have always searched for the hidden structure of existence. Ancient civilizations once believed matter was made from simple elements like earth, air, fire, and water. Those ideas survived for centuries because they seemed to explain the visible world reasonably well. But science eventually revealed a deeper truth. Matter contained atoms. Atoms contained smaller particles. Those particles interacted through invisible forces shaping the universe itself. With every discovery, reality became stranger. Scientists discovered that empty space was not truly empty. Invisible fields appeared to exist everywhere throughout the universe. Tiny particles constantly emerged and disappeared inside the quantum world. Reality no longer resembled a simple machine. Instead, it began looking more like a mysterious ocean of energy, probability, and hidden structures operating beneath ordinary human perception. To study these mysteries, humanity built increasingly powerful instruments, and eventually, one machine stood above all others: the Large Hadron Collider at CERN. Imagine a gigantic circular tunnel buried deep underground. Inside this machine, particles are accelerated to astonishing speeds using powerful magnets and advanced technology. These particles race around the tunnel thousands of times every second before colliding with incredible energy. Why create such violent collisions? Because scientists believe conditions inside these collisions resemble tiny moments after the birth of the universe itself. For an instant, hidden particles can appear. New forms of matter may emerge. Unknown forces might reveal themselves. It is almost like smashing open reality to see what lies inside. In 2012, CERN achieved one of the greatest scientific discoveries in modern history. Scientists confirmed the existence of the Higgs boson. This particle had been predicted decades earlier and helped explain why matter possesses mass. Many people called it the God particle, although scientists themselves often disliked that nickname because it created misunderstanding. Still, the discovery was historic. It completed an important part of modern particle physics, but it also created new mysteries. Because despite extraordinary success, scientists realized something disturbing. The Standard Model, humanity's best theory describing fundamental particles and forces, appeared incomplete. It explained many things remarkably well, but not everything. It could not explain dark matter. It could not explain gravity properly at quantum scales. It could not explain why the universe contains more matter than antimatter. And perhaps most importantly, it suggested reality may contain hidden layers still waiting to be discovered. That possibility changed everything. Scientists began searching for cracks within current theories, tiny anomalies, unexpected particle behavior, measurements that refused to match predictions. At first, these anomalies seemed small, but in science, small inconsistencies sometimes lead to enormous revolutions. Think about history. Long ago, tiny irregularities in planetary motion eventually helped transform humanity's understanding of gravity. Small observations changed the entire picture of reality. Now researchers at CERN were noticing strange patterns again. Some particle decays appeared slightly unusual. Certain measurements hinted at behavior not fully predicted by existing models. Results involving particles called muons attracted particular attention. Muons resemble electrons but are much heavier. According to current theories, their behavior should follow precise mathematical predictions. But some experiments hinted at tiny deviations. Tiny deviations may sound unimportant, but within particle physics, even tiny deviations can signal the existence of entirely new physics hiding beneath current understanding. Imagine solving a gigantic puzzle where every piece appears perfect except one small corner that refuses to fit. At first you ignore it. Then you realize that one tiny mismatch may reveal the entire picture is incomplete. Scientists found themselves facing a similar possibility. Could hidden particles exist beyond current models? Could unknown forces influence reality? Could the universe contain structures humanity has never detected before? Some researchers proposed fascinating possibilities. Perhaps hidden dimensions exist beyond the 3 dimensions humans experience daily. Perhaps invisible particles move around us constantly without interaction. Perhaps entire sectors of reality remain concealed behind the limits of current science. And then discussions became even stranger, because some theories suggested CERN might eventually uncover evidence pointing toward entirely new layers of existence. Layers that could fundamentally transform humanity's understanding of reality itself. But here is where things become deeply unsettling. The more scientists searched for answers, the more complicated the mystery became. Because reality was not behaving as simply as expected. And some researchers quietly began wondering whether humanity was approaching the edge of something far larger than anyone imagined. As scientists pushed deeper into the hidden structure of reality, the atmosphere surrounding certain experiments slowly began to change. Publicly, researchers remained careful and disciplined, exactly as science demands. Extraordinary claims require extraordinary evidence. No serious scientist wants to announce revolutionary discoveries without overwhelming proof. But beneath the calm surface of official statements, growing curiosity spread through the scientific community. Because some experimental results refused to disappear. Again and again, tiny anomalies continued appearing inside particle collision data. At first, these irregularities looked small enough to ignore. A measurement slightly outside prediction, a decay pattern behaving unexpectedly, a statistical fluctuation that should eventually vanish with more data. Yet some anomalies persisted longer than expected, and that is when physicists become interested. In science, repeated inconsistencies sometimes point toward hidden truths waiting beneath the surface. Imagine hearing a faint sound behind a wall. At first you dismiss it, perhaps imagination, perhaps coincidence. But then you hear it again, and again. Eventually you begin wondering whether something is actually there. Scientists at CERN found themselves in a similar position. One of the biggest mysteries involved the behavior of certain particles during high-energy collisions. According to current theories, particles should decay into other particles in highly predictable ways. The mathematics behind these processes is extraordinarily precise. In fact, the Standard Model has successfully predicted experimental outcomes with astonishing accuracy for decades. That is what made the anomalies so unsettling. Because reality appeared to be deviating from expectation. Some experiments hinted that particles were interacting differently than predicted. Certain decay rates seemed slightly unusual. And in particle physics, slight differences can imply enormous consequences. Why? Because hidden particles or unknown forces could subtly influence those interactions without being directly visible. Imagine watching leaves moving on the ground. You cannot see the wind itself, but the movement of leaves reveals something invisible acting upon them. Scientists study particle behavior similarly. Particles may reveal hidden structures indirectly. And some researchers began wondering whether unknown physics was quietly revealing itself through tiny distortions hidden inside collision data. One particularly fascinating possibility involved the existence of entirely new particles beyond current scientific models. If such particles exist, they could help explain some of the greatest mysteries in modern physics. Dark matter, cosmic imbalance between matter and antimatter, hidden forces, perhaps even entirely new dimensions of reality. For years, scientists have known something fundamental is missing from humanity's understanding of the universe. The visible universe itself creates this problem. Galaxies rotate too quickly. Gravity behaves strangely at cosmic scales. The universe contains invisible mass scientists still cannot identify directly. Current physics explains many things brilliantly, but important gaps remain. And CERN was designed specifically to search for those missing pieces. The deeper researchers looked, the more reality resembled an unfinished puzzle. But then another unsettling idea emerged. What if the anomalies were not isolated problems? What if they were connected? Some physicists started exploring theories involving entirely new, hidden sectors of reality. According to these ideas, ordinary matter may represent only a small fraction of existence. Invisible particles might surround us constantly, while interacting so weakly that humanity barely notices them. Perhaps entire hidden worlds exist alongside our own. Not fantasy worlds, not science fiction, but physical structures operating according to laws humans do not yet fully understand. Some theories propose the existence of extra dimensions folded invisibly into space itself. Others suggested hidden quantum fields permeating reality. These possibilities sound unbelievable at first, yet modern physics already describes a universe stranger than most people realize. Particles can behave like waves. Quantum entanglement appears to connect distant particles in ways Einstein himself found unsettling. Empty space contains fluctuating energy. Black holes warp space and time. Reality already behaves in ways that would have sounded impossible centuries ago. So scientists remained open to possibilities, even uncomfortable ones. And then public speculation began spreading online. Rumors exploded across social media platforms. Some people claimed CERN was opening portals. Others believed scientists were tampering dangerously with the fabric of reality itself. Videos appeared suggesting hidden experiments were producing terrifying consequences. But most of these dramatic claims lacked evidence. Real science operates much more carefully. Researchers at CERN are not trying to destroy the universe or open supernatural gateways. They are studying particle interactions under controlled scientific conditions. Still, the deeper philosophical implications remain profound. Because experiments at CERN are not merely about particles, they are about understanding existence itself. Every collision represents humanity attempting to uncover the hidden architecture of reality. And sometimes reality answers in unexpected ways. Think about the scale of what scientists are attempting. They are recreating conditions similar to those existing fractions of a second after the Big Bang. Moments when the universe itself was unimaginably hot and dense. Moments before stars existed, before galaxies formed, before planets emerged. Inside these collisions, scientists search for clues about how reality evolved into the cosmos we see today. And perhaps somewhere inside that search lies evidence of entirely new physics waiting to emerge. That possibility creates excitement, but also tension, because history repeatedly shows that revolutionary discoveries often transform civilization in unpredictable ways. Electricity changed human society forever. Nuclear physics changed warfare and energy production forever. Artificial intelligence is already reshaping the modern world. Now imagine discovering entirely new laws of reality. Imagine learning that invisible sectors of existence surround humanity constantly. Imagine proving that current theories describe only a tiny portion of reality itself. Such discoveries could fundamentally alter philosophy, science, and humanity's understanding of existence. And this is why some scientists quietly speak with caution. Not because they are panicking in the dramatic way internet rumors suggest, but because they recognize the enormous implications hidden within these questions. Because every time humanity uncovers a deeper layer of reality, the universe becomes stranger than expected. And perhaps the strangest possibility of all is this: what if reality contains truths so unfamiliar that the human mind is only beginning to approach them? Perhaps the most fascinating part of this entire story is not the machine itself, but what it reveals about humanity. Think about it carefully. On one small planet orbiting an ordinary star, intelligent beings evolved from particles forged inside ancient stars. Those beings learned mathematics, built civilizations, and eventually created machines capable of probing the deepest layers of reality itself. That journey alone feels extraordinary. Humanity went from staring at the night sky in fear and wonder to smashing subatomic particles together at nearly the speed of light. And yet, despite all this progress, the universe still refuses to fully reveal its secrets. Every discovery seems to create deeper mysteries. The more scientists learn, the stranger reality becomes. Long ago, people believed matter was solid and simple. Then scientists discovered atoms. Later, they discovered particles inside atoms. Then quantum mechanics shattered ordinary ideas about certainty and reality itself. Now researchers suspect that even current theories may represent only part of a much larger picture. Imagine climbing a mountain believing the summit is near. You struggle upward for years. Finally, you reach the top. But instead of seeing the end of the journey, you discover an enormous landscape filled with even taller mountains stretching endlessly into the distance. That is how modern physics often feels. Every answer opens another mystery. Every discovery reveals another layer. And CERN may stand at the center of one of the greatest transitions in scientific history. Because if hidden physics truly exists beyond the standard model, humanity could be approaching a major turning point in its understanding of existence itself. Some physicists believe entirely new particles may eventually be discovered. Others think unknown forces may exist beyond those currently understood. Some theories suggest reality contains hidden symmetries woven into the structure of the universe. Others imagine dimensions beyond ordinary human perception. There are even scientists exploring whether space and time themselves emerge from deeper quantum structures. Think about how radical that idea is. Space and time feel fundamental to human experience. Everything we know happens somewhere and sometime. But what if space and time are not ultimate realities? What if they emerge from something deeper that humanity has not yet discovered? Suddenly, reality becomes far stranger than everyday intuition allows. And this is why certain findings at CERN create both excitement and caution within scientific circles. Because revolutionary discoveries do not simply change textbooks, they change how humanity understands itself. When astronomers discovered Earth was not the center of the universe, human perspective changed forever. When evolution reshaped biology, humanity's understanding of life transformed completely. When relativity and quantum mechanics emerged, reality itself became unfamiliar. Now scientists may once again stand near the edge of another transformation. Not because they are secretly terrified in the dramatic way internet rumors often claim, but because genuine scientific revolutions carry enormous consequences. And the truth is, nobody yet knows exactly where this path may lead. Some anomalies observed at CERN may eventually disappear with more data. Science requires patience. Statistical fluctuations happen. Extraordinary evidence takes time. But if even some anomalies survive deeper analysis, they could point toward entirely new physics beyond current understanding. That possibility alone is enough to fascinate researchers around the world, because hidden inside those tiny deviations may lie answers to some of humanity's biggest questions. What is dark matter? Why does gravity behave differently from other forces? Why does the universe contain matter at all? What happened during the earliest moments after the Big Bang? And perhaps most importantly, how much of reality remains hidden from us? Sometimes people imagine science as a process that eliminates mystery, but perhaps science actually deepens mystery, because reality repeatedly turns out more astonishing than expected. Invisible quantum fields, curved space and time, black holes warping the universe, dark matter surrounding galaxies, dark energy accelerating cosmic expansion, and now the possibility that hidden layers of physics may exist beyond everything humanity currently understands. The universe appears far more mysterious than ancient civilizations ever imagined. Yet the human desire to understand remains unchanged. Across thousands of years, people looked upward and asked questions. Who are we? What is reality? How did existence begin? What hidden forces shape the cosmos? Modern science continues that ancient search, using mathematics, experiments, and technology instead of mythology alone. But the emotional drive remains remarkably similar. Wonder, curiosity, the desire to know. Perhaps that is why stories about CERN capture public imagination so powerfully. Because deep down, people sense that these experiments touch something profound. They are not merely about particles, they are about existence itself, about uncovering hidden truths buried beneath ordinary experience, about humanity attempting to understand the deepest structure of reality. And perhaps there is something beautiful about that search. Because despite disagreements, debates, and uncertainty, humanity continues exploring. Scientists continue asking difficult questions. They continue testing ideas. They continue challenging assumptions. And somewhere inside massive underground tunnels beneath Europe, particles continue colliding at incredible speeds, while researchers search for answers hidden within the fabric of existence itself. Maybe future discoveries at CERN will reveal entirely new particles. Maybe hidden dimensions truly exist. Maybe dark matter will finally be identified. Or maybe the universe will surprise humanity in ways nobody currently expects. History suggests that reality often behaves differently from imagination. And perhaps the greatest lesson from modern physics is this: the universe is under no obligation to match human expectations. Reality may ultimately prove stranger, deeper, and more mysterious than anything humanity has yet imagined. What CERN just caught may or may not rewrite science completely. But one thing is certain: the search itself is changing how humanity sees the universe. And perhaps somewhere beyond current knowledge, beyond existing theories, beyond everything scientists presently understand, reality still waits with secrets yet to be revealed. What do you think? Comment below. Subscribe to DIHAZ IGNAS.